Good afternoon, Professor. Good afternoon, all my friend FDSIP. My name is Angga Wahyu Wibowo with student ID 2296096 with my supervisor R. Yasufumi Takama, Professor, and Professor Eri Satoshi Mokawara. I'm a first doctoral in the Department of Computer Science. I want to present about my research with the title Greeting Gesture Classification Using Machine Learning Based on Politeness Perspective in Japan. So first, I want to talk about my background. First, cultural norms passed down to future generations are in danger because globalization has grown. And second, gesture can express message according to each culture. Third, politeness is essential to interacting social which reflect the community to others. Four, a behavior can create a representation of an activity. However, some behavior does not represent the culture. So my summary of the background are the culture is important for us, especially for the some generation. And behavior can represent the culture, but the many research about the behavior, but not represent the culture. So in this research, I focus on the behavior that represent the culture. We go to the contribution. First, research on behavior that represent a culture. It means uh, it combined with behavior and culture. And then the second is it is the first study that classify the greeting gesture with the politeness perspective that represent the culture of Japan. I focus on the eshaku, kere, and shaikere, and waving hands. It's the part of the greeting style in the Japan with the perspective of point of view. By utilizing and comparing the result between KNN with Euclidean distance, KNN with dynamic time warping, and support vector massive. So for proposed method, I use a 3D human skeleton joint. So we use the joint coordinate of the 3D human skeleton. The joint coordinate have a length of 3 multiplied by 332. So we can see in this picture is the skeleton of human with we use Microsoft Azure for the represent the 3D human of skeleton. We have the eye right, nose, eye left, ear left, head, neck, clavicle left, shoulder left, elbow left, wrist left, hand left, thumb left, hand tip left, and then in the right we have clavicle right, shoulder right, elbow right, wrist right, hand tip right, and thumb right. And then we have spin, chest, spin navel, pelvis, hip left, right, hip right, knee right, and ankle right, foot right, and knee right, ankle left, foot left, and knee left. So we have 32 skeleton of joint. And then we remove unnecessary joint like hip right, knee right, ankle right, foot right, hip left, knee left, ankle left, and foot left. So we remove this part because for the bowing it's not necessary for the bowing. And then we calculate frequency domain and discriminative frequency design scale variance data maximum, minimum, and interquartile range. Yes. So this part we have some preprocessing data. Then for the experiment, for Esaku, we have like this 3D skeleton and scary, shakiri, and web. So difference about the Eshaku, Kere, and Shakere is the part of when we like a bowing. When Eshaku is 15 degrees for bowing, Kere is 30 degrees for bowing, and Shakere is 45 degrees for bowing. And wave is only used for hands. And then we use 10 participants with conducted with 3 seconds for bowing, and 10 participants we collect, we have 92 dataset for 4 behavior: Shaku, Kere, Shakere, Wave. And then we use training data for 80 and 12 for testing. We classify and compare with KNN and Euclidean distance, and KNN with dynamic time working, and SVM. So for the result evaluation, for the KNN with Euclidean distance, we have accuracy with 79%. For the precision, we have 88%. And recall, we have 80%, and F1 score, we have 79%. For KNN with dynamic time working, we have 62%, and for precision, we have 68%. And then for recall, we have 62%, and F1 score, we have 60%. And for SVM, we have 65%. For precision, we have 86%. And for recall, we have 65%. And F1 score, we have 66%. So we can compare with this part. Canon with Euclidean distance have more height than Canon with dynamic time mapping and SPM. And then we can see for the confusion matrix, for the Canon with Euclidean distance, we know that Eshaku, Keri, and Shekere have the powerful bowing for this method. And then for KNN with dynamic time warping, we see that only waves that have a superior good result we compare with the Sekiri and Asia. But for Keri, it's only bad performance for KNN with dynamic time warping. And for SVM, we know that Asia2 and wave is best for the behavior compared with the Keri and Shakiri. So we can see that KNN with Euclidean distance can be a good algorithm for this behavior with a small dataset with only 92 dataset. For the conclusion and future work, conducting the greeting of Eshaku, Kere, and Shakere are challenges because the three greetings have the same motion, which is only distinguished by the level of depth when bowing. Distinguishing between waving and bowing is not as difficult as comparing the greeting of Eshaku, Kere, and Shakere. It shows the level of politeness to others. So it means that in Japan, we research about the level of bowing, like Eshaku, Kere, and Shakere. But it have challenges because Eshaku, Kere, and Shakere have the same motion, same start, and same end. But the difference about three behavior is about the angle. Eshaku with the 15 degrees, Kere with 30 degrees, and Shakere with 45 degrees. So it has challenges for for us to recognize the Asia pool carry and shake it. But with the waving hand is the different style because waving hand only use like this, but the bowing have a different style of different behavior. And then the KNN with equilibrium distance method give high result compared to KNN with dynamic tone mapping and SVM method. It I can I can analyze with Canon with equilibrium distance because Canon with equilibrium distance it calculate the base of the distance between one data to other data. And then for future work, investigate creating behavior from other culture from different perspectives to understand culture difference in creating gesture across countries and across culture in future work. Like we can investigate like Indonesian style or Malaysian style or Thailand style or other country style or in the Japan, but another greeting style for future work. Thank you very much for acknowledgement. This work was supported by the SPS Calcuni fostering joint international research grant number GP22KK0162. So I think finish my presentation about my research in the first year in the doctoral degree in the Department of Computer Science. Thank you very much and